Today it's May, week 1, and we're doing 3rd grade math, and we're going to be finding out how to do area of a triangle. Please get your sheets that say area of a triangle, and we're going to look at some questions. Question 1. What is a rectangle? A quadrilateral with 2 pairs of parallel sides and no right angles. A quadrilateral with 2 pairs of parallel sides and 4 right angles. A triangle with a right angle. A quadrilateral or a triangle who wrecks things. Yeah, I know you all want to pick the last one for the rectangle. But what's the right answer? Yeah, the second one. Okay. Number 2, how do you find the area of a rectangle? Build a fence around it and say, "This is my area." Fill it up with air. Measure all around it and add up all the sides. Length times width. All right, it's length times width. This third choice is perimeter. And sometimes kids get those two things confused, but for area of a rectangle, it's length times width. 3, find the area of Joe. She is a special kind of rectangle. A, yes, a square. Area of Joe equals, just copy this, right? Length times width. Okay. Which equals what? Well, we're going to count from the bottom. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for the length times, and now we'll do the width starting at this corner, and we'll say that's 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again. Length times width, 10 times 10, and I hope you guys all know what that makes. Equals 100. 4, draw a line from Joe's chin to her right shoe. Use a ruler. Hopefully you guys have a ruler. If you don't, use the edge of a book. From her chin to her right shoe. Draw another line from Joe's chin to her left shoe. Use the ruler. Okay, again, we're going to start at her chin, and this time we're going to go to her left shoe. If you don't have a ruler, please use something straight. You have made a triangle. What is the length of the base of the triangle? So the base is the side that the triangle sits on. And we already actually counted that. It's 10. Is that the same measurement as the length of the rectangle? Well, we said the length was 10, so is it the same? Yes. 6. What is the height or altitude of the triangle? Now, you guys live in the mountains, and you know that if you hike up one of our mountains, the height is not the distance from where you start your hike to the summit. It's the distance from if you drilled a straight line down from the summit to the center. That's called the height or the altitude of the mountain. This is a little further. So we want to know just if you had a straight line. So do you guys remember? We actually counted that, but let's do it again. We're going to start down here and count from 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You should be right at Joe's chin. So the height is 10. Is that the same measurement as the width of the rectangle? Well, yes, we measured the width, and it was 10. Width was 10. 7. Okay, now carefully cut out the rectangle, Joe. Then carefully cut out the triangle. Don't lose any of the pieces. There will be 3 pieces. Start by cutting out the rectangle, which is a special kind. It's called a square. I'm afraid you're going to have to cut off her head. And then cut out the triangle and keep all the pieces. Okay. Let's go to number 8. Do the 2 side pieces exactly match Joe's dress? Well, put them on Joe and see if those 2 smaller pieces match Joe's dress, which is the triangle. So we're going to take our first piece and put it on one side. Take the second piece and put it on the other side and see if it exactly matches. And mine does. Let's read the next part of number 8. If they exactly match, that means that Joe's dress and the 2 side pieces are exactly equal. Are the 2 side pieces equal to half of something? What? Well, guys, if this and her dress exactly match, then the 2 side pieces must be equal to exactly half of our original rectangle. Her dress must be half, and the 2 side pieces must be the other half. So up here, we're going to write yes, they exactly match her dress, and if they're equal to half of something, what is it? Well, it's that rectangle or square. We're just going to say the rectangle. We all know that it was a special kind of rectangle called a square. Is Joe's dress equal to the other half of something? What? Well, if those pieces were half of the rectangle, then her dress must be the other half. So we can write it again, the rectangle. Now down here it gets interesting. So we can say the area of a triangle is half of the area of the rectangle that the triangle fits into. So the area of a triangle equals half of length times width, right? Because in order to get the area of a rectangle, you got to do length times width. So the area of a triangle equals half length times width. So the area of Joe's dress is half of 10 times 10, which is half of 100, which is 50. Now there's no way for you to figure that out by counting squares because the squares were all in little pieces along the edge of the triangle, right? If you think about that triangle, Joe's dress, you can't count the squares. You cannot measure the area of a triangle by doing length times width, but you can get it from doing half of length times width. Pretty cool, huh? You should have another sheet that looks like this, that has a little 2 at the top, and it also says area of a triangle. Okay, so if you guys have time, go ahead and get your sheet out and go to number 1. What is the area of this rectangle? Slip. You can see Slip has a banana peel that he's going to slip on. So, what is the area of this rectangle? Slip. Area equals length times width. Okay, and they want us to write the length. So let's start. Length is the longer side. We'll start down here at the banana. 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Width is the shorter side. Start here and say 0, 1, 2, 3, 4, 5. And if area is length times width, then that's 10 times 5. So we'll count our 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So Slip's area is 50. 2. Draw a line from Slip's cheek to the banana. Use a ruler. You have made a triangle. 3. What is the height or altitude of this triangle? Remember, the height is not this. The height would be if you went straight up from the bottom to the top. and that's called the summit. On a triangle, that's called the apex. On a mountain, it's called the summit. And I don't know if you guys remember, but we actually counted that, but we can count it again on this side. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the height of this triangle is 10. Is that the same measurement as the length of the rectangle? You said that the length was 10, so yes. 4. What is the length of the base of this triangle? So the base is right here. You could say Slip is sitting on his base. And we're going to count 0, 1, 2, 3, 4, 5. Is that the same measurement as the width of the rectangle? Yes. 5. Okay, now carefully cut out the rectangle, Slip, then carefully cut out the triangle. Don't lose any of the pieces. There will be 2 pieces. Six. Do the 2 pieces exactly match? If they exactly match, that means that they are exactly equal. Well, let's look. Looks to me like they do. So we're going to write yes. 7. Is the piece with Slip's name on it equal to half of something? What? So if it's exactly equal to this part, it must be half of something. What is it half of? And here's a little clue. It's half of our rectangle that we started with. Is the other piece equal to the other half of something? What? So if this piece is equal to half of something, what's this piece equal to half of? It's that rectangle. So we can say the area of a triangle equals half of the area of the rectangle that the triangle fits into. So the area of a triangle equals half length times width. So the area of this triangle equals half of 10 times 5. Remember when you figured that out? Which is half of 50. What's half of 50? Well, 50 cents is 2 quarters, so 1 quarter is 25 cents. So if 1 quarter is half of 50 cents, then something cents must be half of 50 cents. 25. So half of 50 is 25. I'm sure most of you knew that. So the area of this triangle must be, well, it's got to be 25. And you can't get that from counting the squares. You cannot get that any other way than figuring out the length and the width of the rectangle that this triangle fits into. And then dividing that into half. Can you figure out the area of a triangle by counting the squares? Well, no, you can't. So how do you figure it out? Area of a triangle equals, let's see, what did you guys learn? Half. And then we're going to put parentheses, length times width. The only thing I want to remind you about is when you're figuring out the length of a triangle, the height of a triangle, which will be the length of the rectangle, don't forget that's going to be the distance from the base of the triangle straight up to the top. It's not going to be the sides. I also have a little story to tell you. So we've had a lot of lambs. They're pretty cute. And I wanted to tell you a story about a sort of a sheep story because of all the lambs we have. Bruce's dad used to herd lots and lots of sheep, thousands. And they lived over on the flat tops near Glenwood Springs. And they'd have to take the sheep all the way to Denver. And they hiked. They took the sheep, just walked them all the way to Denver, usually in the fall because that's good butchering time. The reason fall is good butchering time is that the meat stays cold during the winter. So they would take these thousands of sheep over the mountains and all the way to Denver, and the sheep would be eaten along the way. They'd be finding stuff in the forest to eat and a little bit of this, a little bit of that. But Denver at that time had a lot of potato and onion fields all around. And Grandpa and his buddies that took the sheep over there, when they got near Denver, they would have to buy a hose at a hardware shop, and then they would cut the hose into pieces about this long. And when the sheep were foraging for the frozen potatoes and onions, especially the onions, onions are shaped like a ball. And I want you to imagine a frozen onion that was like a hard, almost like a baseball, okay? And the sheep knew that that was good to eat because he could smell. And they'd swallow the frozen onion, but that onion would get stuck in the sheep's windpipe. And then Grandpa and his buddies had those lengths of hose, and they'd run around, and if they saw a sheep that was choking, they would take the pipe and shove it down the sheep's mouth right to about here, and then they'd blow as hard as they could. And believe it or not, that would pop that onion down into the sheep's gullet, and then the sheep could breathe again. They actually had to do that a few hundred times in those fields before they got the sheep to Denver, to the stockyards.